Hello everyone, how are you today? I would like to provide today a short lecture or discussion of the concept or the tool that we use frequently in economics we call elasticity. I really don't think there is another concept in intermediate microeconomics that is quite as overcomplicated by students as the idea of elasticity. Elasticity is actually a very simple idea, and it shouldn't really be a problem for anybody to easily grasp and use, because what we're talking about here is an elasticity is simply the ratio of the percentage change in one variable over the percentage change in another variable. And it captures how these proportionate changes affect one another. So, for example, we're going to talk about price elasticity of demand. All the price elasticity of demand is the percentage change in quantity demanded observed following a given percentage change in price. That's it. And since we have percentage in the numerator and we have percentage in the denominator, the measure, percentage changes, cancels out, and we're just simply left with a pure number. And that pure number is simply the ratio of the percentage change in quantity demanded to the percentage change in price. So any elasticity that is greater in absolute value than 1 suggests that the percentage change in quantity demanded that arises from a given percentage change in price is greater than the percentage change in price. So a 10% change in quantity demanded over a 5% change in price says elasticity is 2. The percentage change in quantity demanded is twice the percentage change in price. Now, we frequently speak of elasticities, demand elasticities, as positive numbers, but we know that when price goes up, so a 5% increase in price causes a 10% drop in demand, quantity demanded, then we would have an elasticity of -2. But in absolute value, that's greater than 1. If we have an elasticity equal simply to -1, that says that a given percentage change in quantity demanded that arises as a consequence of a given equal percentage change in price then yields a ratio that has same value in the numerator, same value in the denominator, one of them being negative, so that's equal to -1. And of course, then anything less than 1 in absolute value suggests that the percentage change in quantity demanded is less than the percentage change in price. That's it. I mean, we have elasticities for all kinds of different relationships. Whenever any variable is dependent on another variable, we can form an elasticity. We just look at the percentage change in the dependent variable over the percentage change in the independent variable. That's it. It's no more complicated than that. And then we interpret the number. But we interpret the number, like I said, in absolute value, greater than 1, equal to 1, or less than 1. That's what we can say. And it's very useful for us. We'll show an application here today of how useful it can actually be. So, as I say, of interest to us in economics, of course, is the sensitivity of quantity demanded to price. And there are several other relationships that we're interested in, but we kind of focus on this one today. And then at the end of this little lecture, we'll look at some of these other ones. But all elasticity is, as I said, is a percentage change in a variable in response to a given percentage change in another variable. And price elasticity of demand then, generally that's what elasticity is. More specifically, price elasticity of demand is simply the percentage change in quantity demanded in response to a given percentage change in price. And we know that quantity demanded is a function of price. So as price goes up, quantity demanded goes down. But what we end up with here, since we have a percentage change in quantity demanded divided by a percentage change in price, what we get is the percentage change in the numerator and the denominator cancel out, and we get a pure number that gives us simply that ratio. And it doesn't really matter what units the numerator or denominator are measured in. You know, if we think of price being dollars or we think of price being in pennies or cents, that's a difference of 100 in the units, but the percentage changes would always be the same. You know, if we go from $1 to $2, we're doubling, or we have a 100% increase in price. If we go from 100 cents to 200 cents, we again have a 100% increase in price. It completely eliminates the problem of what our variable unit is. Now, how do we capture this? Well, this elasticity, which we use as epsilon for, is simply, as I said, the ratio of percentage change in quantity demanded over percentage change in price. Well, how do I calculate the percentage change in quantity demanded? Well, I look at the actual change, the absolute change in quantity, and I divide it by whatever its initial value was. So if initially quantity is 100, and we have a 5-unit change in quantity, that would be a 5% change in quantity demanded. And the same for price. The denominator here, we have the change in price from whatever its initial value is, divided by that initial value, and that gives us a proportionate or percentage change in price. So that if price was initially $1 and it increased to $1.05, that would be a 5-cent change in price divided by a $0.05 change divided by $1, that would be a 5% change in price. And just taking this expression, this delta Q over Q over delta P over P, what you can see is we rearrange it and we can state it as delta Q over delta P, which is the slope of the demand relationship, times the ratio of initial price to initial quantity. This is just for calculation purposes, but it doesn't change in any way, shape, or form the interpretation. So going the wrong way, delta here we use, of course, to indicate change. So if a 1% increase in price, a 1% increase in price results in a 3% decrease in quantity demanded, then calculating elasticity, it says that our elasticity is equal to minus 3% over 1%. The percents cancel out, and we end up with a number minus 3. And I look at that number and I say, wow, for a given percentage increase in price, demand is going to fall by 3 times that percentage increase in price. Not demand, I made my own mistake. Quantity demanded is going to fall by 3 times the drop in price. Now you can see how important this would be to business people who are contemplating a price change. If they know their elasticity, they can use this construction to get a good grasp of what's going to happen if they undertake a price change. If they want to increase their sales, they know they have to lower their price. How much do they want to increase their sales? Well, they want to increase their sales by 10%, and they know their elasticity is minus 3, well, that tells them that they would have to lower their price by 3 1/3%. And if they lower their price by 3 1/3% with an elasticity of minus 3, that would suggest then that their quantity demanded will increase by 10%. Now, coming back, what we're normally working with in this class are linear demand curves. And so we have quantity is equal to A minus B times own price. And B is the slope of the demand relationship here. So minus B is equal to then delta Q over delta P. Think about this expression right here. For a change in price of delta P, we would have then a resulting change in quantity of delta Q equal to minus B times delta P. A is a constant, so it doesn't change. The only thing that changes with a change in price is this term here, minus B delta P. And that generates a change delta Q. Well, if we rearrange that expression, we end up with this slope is just delta Q over delta P. Then at any given point on this linear demand curve, the elasticity of demand is simply minus B times, we're at a point, which is price and quantity, P over Q. All right? That's it. Simple. Now, here's an example. Estimated linear demand function for pork is Q equals 286 minus 20P, where Q is the quantity of pork demanded in million kilograms per year, and P is the price of pork in dollars per year. All right, so P is measured in dollars. Excuse me. Where Q is the price of pork, Q is the quantity of pork in millions of kilograms, and P is price in dollars. Now, those are both units, but that doesn't do us much good. It generates interpretation problems. So what we need to consider is, suppose initially the price of pork is $3.30 and Q is equal to $2.20. Then calculating elasticity of demand at that point on the demand curve, I have minus B, which is minus 20. And then I take the initial price and quantity, 330 over 220, and that says that elasticity is equal to minus 0.3. So that tells us, if I want to interpret that the change in the percentage change in quantity demanded is just 0.3 of the percentage change in price. Now, that suggests to me that demand for pork is not very sensitive to changes in price. There's a relatively small percentage change in quantity demanded for any given percentage change in price. So here we are looking at this. We started at 330 and 220. This is that point on the demand curve, and we calculated elasticity at this point using this initial value 220 for quantity and 330 for price. And of course, the slope of the demand curve is minus 20. The slope of this curve is, however, again, back to that issue, this is the indirect demand curve. I'm not using the slope of the indirect demand curve, which would be minus 1 over 20 or 0.05. I am using the slope of the demand relationship, which is not what we have graphed here. We have the inverse demand curve graphed here. So calculate the elasticity of demand for the linear pork demand curve in the previous slide at the equilibrium where price equals 320. So we already calculated this. The estimated linear demand function for pork, which holds constant other factors influence demand. We have that, and we calculate it again as at that point. Remember, this is specific to that point on the demand curve, where P is equal to 330 and Q is equal to 220. We calculate a price elasticity of demand of minus 0.3. All right, so a 1% increase in the price of pork leads to only a 0.3% decrease in the quantity of pork demanded. Quite insensitive. Demand to quantity demanded is quite insensitive to changes in price. Now, because of the way we calculate the elasticity of demand along a linear demand curve, we're saying it's equal to minus B times P over Q, right? That was what our expression was here. Minus B times P over Q. And so the B is going to stay constant. But as we move along the demand curve, the value of P and the associated value of Q are going to change. So since this ratio changes as we move along the demand curve, elasticity of demand is going to vary as we move along the demand curve. So along a downward sloping linear demand curve, the elasticity of demand is a more negative number the higher the price is. Now what they're saying is elasticity of demand increases in absolute value as we move up the demand curve, right? Because P is getting bigger and Q is getting smaller as we go up the demand curve. So as I move up this curve here, I have a very low P and a very high Q. So the ratio P over Q is very small. As I go up this curve, P is increasing and Q is decreasing. So that ratio P over Q is increasing. And since minus B stays constant, the value of price elasticity of demand will be increasing in absolute value. All right, so when we get to the top of this curve, we have an epsilon, at a price of 11.44 and a quantity demanded of 57.2. Elasticity demand at this point is -4. So that tells us the sensitivity of quantity demanded to changes in price has increased significantly. Now, when we're at the very top of this demand curve, a 1% increase in price would generate a 4% decrease in quantity demanded. Now, that strikes me as a sensitive quantity demanded to price, sensitivity of quantity demanded to price. All right, so just calculating this here, 11.44 over 57.2 minus B minus 20 times that ratio P to Q. Down here we said was minus 0.03 insensitive. Up here it's become -4 sensitive. Now if you think about really what's going on here, if we just think about equal incremental movements up this demand curve, remember the slope is constant. The slope is -1 over B. If we think about equal incremental changes up this in this demand relationship here, the base that we're using to calculate the percentage change in Q is decreasing. So for any equal incremental change in Q, since the base is decreasing, it's becoming a larger and larger proportionate or percentage change in Q. And equivalently, as we move up this demand curve, we're going from a low price, which meant for some equal incremental change in price. As the base value goes up, the percentage change is falling. So a nickel change from a base of 330 is a lot larger proportionate change than a nickel change from a base of 11.44. So the percentage change here is falling. By the same token, a change of 20 units in quantity demanded is a much smaller percentage of 220 than it is of 57.2. So as we move up the demand curve, this percentage change is increasing, this percentage change is falling. So in absolute value, the ratio of this percentage change over this percentage change is increasing in absolute value. Right in the middle of this demand curve, right smack dab in the middle, along both axes, is a point that we call unitary elasticity of demand. And so we start out here at the bottom of the curve below 1 in absolute value. And as we move up the curve, elasticity is increasing in absolute value. Boom, we hit the middle point. It's equal to 1. And then as we move above this point, the absolute value is increasing up to this point here, 4. But so we have one point where we switch from elasticity being less than 1 in absolute value to elasticity being greater than 1 in absolute value. And we call any elasticity which is less than 1 in absolute value, or in that interval between 0 and -1, greater than -1, which would be less than 1 in absolute value, we call that inelastic. And whenever the absolute value of elasticity is greater than 1, we call that elastic. Inelastic suggests price insensitivity of quantity demanded. Elastic suggests price sensitivity. This suggests insensitivity because the percentage change in quantity demanded will be less than the percentage change in price. So that suggests that quantity demanded is not very sensitive to price. Over here on the elastic portion of the curve is where the percentage change in quantity demanded will be greater in absolute value than the percentage change in price. So that suggests sensitivity or an elastic demand. And right here in the middle at this midpoint where elasticity is equal to -1, it simply says right at that point, for small changes, the percentage change in quantity demanded will be exactly equal in absolute value to the percentage change in price. There's another point again. Here's our point 3 coming back. So along a linear demand curve, elasticity is variable. Now let's think about polar cases here. Suppose in a perfectly competitive market, a firm faces a horizontal demand curve. A horizontal demand curve. We say, by convention, that elasticity is infinite. It's perfectly elastic demand. Because an increase of 1 cent in price causes quantity demanded to go to 0, a decrease of 1 cent in price would result in an infinite increase in quantity demanded. So just by convention, a horizontal demand curve is deemed to be perfectly elastic. And the other extreme case is a vertical demand curve. Elasticity is 0 because if the demand curve is vertical, a change in price cannot result in a change in quantity demanded. So here, any change above or below this price either takes us to infinity or to 0. Here, it doesn't matter what the price is, the quantity demanded stays the same, so the numerator in our elasticity expression will always be 0, therefore elasticity demand is 0. Here's a demand curve that illustrates sort of both, an individual's demand for insulin up to their required doses per day is infinitely elastic. And once then they have acquired their necessary doses per day, demand becomes inelastic. They have no more use for insulin that day. All right, so let's think about this. Whenever equilibrium price changes, let's just suppose that there's a change on the supply side that's pushing price up or down. So we're moving along a demand curve. Whether total revenue increases or decreases will depend on the elasticity of demand at the point on the demand curve where we were when the shock happened. So as we said this, if we think about if we're on the elastic portion of the demand curve, that is above the midpoint, going up to the left, if price goes up by 1%, demand will fall by more than 1%. So the net effect of these two changes is going to be, as price goes up, moving along the elastic portion of the demand curve, the net effect will be a greater decrease percentage-wise, proportionately, in quantity than the increase in price. So the net effect will be negative. The net effect will be negative. Think about going in the other direction along the elastic portion of a demand curve. If for some reason price falls by 1%, that would cause revenues to fall by 1%. But if as a consequence of that 1% decrease in price, the quantity demanded increases by 3%, that 3% additional quantity sold would tend to cause revenues to go up by 3%. So we have a 3% increase due to the change in quantity demanded, a 1% decrease due to the decrease in price. The net effect would be a 2% approximately increase in revenues. So moving along the elastic portion of the demand curve, an increase in price would have the effect of causing revenues to fall. A decrease in price would have the effect of causing revenues to increase. Now it's the exact opposite if we're on the lower or the inelastic portion of the demand curve. If you think about what an increase in price of 1% does, if it causes quantity demanded to fall by 0.5%, the increase in price would tend to make revenues go up by 1%. The decrease in quantity demanded by 0.5% would tend to make revenues fall by 0.5%. So on balance, we would experience a 0.5% increase in revenues because the increase in price proportionately outweighed the proportionate decrease in quantity. And conversely, going the other way, if we were to lower price by 1% or observe a drop in price of 1% and we're on an inelastic portion of the demand curve, we lower price by 1%, that causes revenues to fall by 1%. But since we have a downward sloping demand curve, if there is, at the same, as a consequence of that 1% decrease in price, a 0.5% increase in quantity demanded, which is what would reflect an inelastic demand, then the 1% drop in price would outweigh the 0.5% increase in quantity, and we would observe a drop in revenue. So along the inelastic portion of the demand curve, an increasing price suggests increasing revenues. A falling price would result in decreasing revenues. So if we think about this, being here on this inelastic portion of the demand curve down here, let me see what all we got here. An increase in price does two things. On the one hand, when we go from E1 to E2, that causes this drop in quantity. So this is a revenue loss here. Price times quantity is this area. This is the revenue loss. This is delta Q down here. So this is a loss, but the increase in price, even though we're selling less, generates additional revenues that are gotten as a consequence of the higher price. Now, whether revenues increase or decrease is going to depend on whether this area C is greater than or less than this area B. If C is greater than B, then the gain in revenues from the higher price exceeds the loss in revenues from the lower quantity. So does revenue increase or decrease if the demand curve is inelastic at the initial price? Well, answer, consider the extreme case where demand curve is perfectly inelastic and then generalized in an inelastic case. If demand is perfectly inelastic, as price goes from E1 to E2 or P1 to P2, we get a increase in C and no loss due to a drop in quantity, so sure, it's going to increase revenues. If it's relatively elastic, no, we get this big drop in revenues due to a large quantity adjustment relative to the increase in price. And we have now a relatively small increase in revenue due to the higher price because of the significantly reduced quantity demanded. So perfectly inelastic, higher price increases revenues. Relatively elastic, then we get a big drop as a consequence, big drop in revenue as a consequence of the sensitive quantity demanded to the increase in price, and not a big increase in revenues due to, relatively speaking, due to the increase in price, so that in this case, we would expect total revenues to fall. All right? So think about this. If we go back to a demand curve here, let me get to one. Over this interval of the demand curve, demand is inelastic, so as price is going up over this interval, revenues are increasing. But they're increasing at a decreasing amount. Ultimately, when we get right to this point where demand is unit elastic, we have an equal value, we have equal ratios equal to -1. That means the percentage change in quantity demanded is equal to the negative of the percentage change in price. So that says if we were to raise price by 1%, quantity demanded would fall by 1%. Those two effects would just offset one another in terms of revenue. So right here, we would have a change in revenue of 0. So as I'm going up this demand curve, remember, revenues are increasing, but at a lesser and lesser rate. Finally, boom, when I get to here, revenue change is 0 because the price and quantity effects offset one another. Now, as I move over this portion of the curve, the elastic portion of the curve, as I increase price, revenues are falling. I get to this point right here, where quantity is 0, revenues are 0. Moving down the demand curve, revenues are 0 at this point on the intercept. As I move down, revenues are increasing as price falls, but they're increasing at a lesser and lesser rate. Boom, 0. And now revenues start to fall as I lower price. And ultimately, I get down to here where price is 0, revenues would be 0. So revenues are actually maximized. Revenues, not profits, revenues are maximized at the midpoint, or where the price elasticity demand is equal to -1. Now, here's another, we have all sorts of these elasticities, but they're all the same idea. In this particular case, sensitivity of quantity demanded to income, all else equal, would simply be the ratio of the quantity demanded to the percentage change in quantity demanded over the percentage change in income. And here's an example. This isn't the notation we've been using in the class for income, delta Y. We're using M in your textbook, but you can see the calculation is exactly the same. Only in this case, we would use the coefficient in the demand relationship, the coefficient of income for this linear relationship in our elasticity calculation, and then it would simply be, rather than price in this case, the initial value of income over the initial value of Q. Same idea here for the price of a related good. Suppose we're talking about some other good, a complement or a substitute. Same deal. It's going to simply be the proportionate change in Q over the proportionate change in that good. So if we have, PB that has a coefficient of 20, that's what we would use. If we had, price of chicken here, its coefficient is 3. These would both be substitute goods, and I know that because if the price of beef goes up, people would substitute away toward pork, so my Q would increase. Or if the price of chicken went up, people would substitute away from chicken, toward beef and pork. So what do we have here? We have two coefficients on these two substitute goods of 20 plus 20 and plus 3. The coefficient has to be positive. So in this particular case, I do exactly the same way. I take that coefficient and I multiply it then times the initial price of the substitute good over the initial quantity demanded at that point in that demand relationship. So if cross-price elasticity is positive, the goods are substitutes. Cross-price elasticity will be positive when that coefficient is positive. And if cross-price elasticity is negative, then if the coefficient on that price of the related good in the demand equation is negative, that says when that price goes up, demand for this market's good goes down, they must be complements. Now, as always, we interpret the value of the elasticity in the same way. Whenever the absolute value, in this case, is positive because we're looking at a substitute, whenever the value, the absolute value of that elasticity is greater than 1, it suggests sensitivity. And whenever the value of that elasticity, the absolute value of elasticity is less than 1, it suggests insensitivity. Or in other words, when it's greater than 1, we call it elastic. When it's less than 1, we call it inelastic. All right, same deal here. No need to go on with this, but quantity supply, we have the exact same thing. You know, elasticity of supply, price elasticity of supply is just a percentage change in quantity supplied over percentage change in price. Once again, the calculation is equivalent. The interpretation is equivalent. So, you know, if we want to think about, you know, here's a supply relationship. I don't know why it's a negative. It should be a positive. But we make the same calculation as always. We have this coefficient 40 times some initial value of P, some initial value of Q. And so we calculate the elasticity of supply. In this case, the elasticity of supply is 0.6. That tells me for a 1%, well, I'll make it easier, for a 10% increase in price, the quantity supplied would increase by 6%, relatively insensitive or inelastic supply. All right, so this is the same. Elasticity of supply is going to vary along the supply curve as well, because again, it uses that ratio P over Q, and that's going to vary along the supply curve. So as you can see, what's going on as we go up the curve is elasticity of supply is increasing. Exactly as it does with the demand curve, but the demand curve was negatively sloped, but it was increasing absolute values as we went up the demand curve. Now it's increasing as we go up the supply curve as well. So that's elasticity, but like I say, it just distills down to a simple ratio. It is just the ratio of percentage change in one variable to percentage change in a second or another related variable. And whenever that relationship is greater than 1 in absolute value, it suggests sensitivity, or what we would say is elastic relationship. And whenever that absolute value is less than 1, it suggests insensitivity of the variable in the numerator, changes in the variable in the numerator to changes in the variable in the denominator. And we would deem that to be inelastic. So don't overcomplicate it. You don't have to. And if you don't overcomplicate it, you'll find it's a pretty useful measure. You can talk about it. It's a great shorthand measure. All righty, bye-bye.